Welcome back to this course on ILP, DLP and TLP. This lesson starts a new module on exploiting DLP using SIMD instructions. The purpose of this lesson is to give an introduction to SIMD instruction set extensions. Here's an outline of this lesson. First, I will motivate and introduce you to the general concept. Then I will talk about the register file and data types supported by SIMD extensions. Then I will talk about arithmetic instructions and saturation. And finally, I will talk about the challenge of multiplication. This is a very old picture of a Pentium processor, and it says with MMX technology. And in this lesson, I will talk about MMX, which some people believe to be the acronym of Multimedia Extension. Very often on our digital platforms, we execute multimedia applications, and they require very high performance. What are characteristics of multimedia applications? First, they process small data types. For example, 8-bit pixels for images and for videos, or 16-bit audio samples, or 12-bit DCT values. DCT is the abbreviation of discrete cosine transform, which is an important kernel in multimedia applications. And of course, 8 or 16 or 12-bit is much smaller or much narrower than the width of a typical data word size. For example, MIP64, that's the 64 in the name, uses 64-bit data words. That means that a lot of the processing capability of these wide data words of processors is wasted. The idea is, another characteristic of multimedia application is that they have or exhibit fine-grained data level parallelism. That means that the same operation is performed but on multiple data elements, and all these operations are independent. For example, images are two-dimensional, or we have, if we add the dimension of time, we have video applications. The basic idea behind SIMD is that one instruction performs the work of multiple operations in one instruction and at the same time. Here we have a very simple illustration of a very simple SIMD instruction where the operation op, indicated here in this circle, is performed in parallel to all elements contained in a small vector register, and the result is placed in another vector. So SIMD is the acronym of single instruction, but on multiple data elements at the same time. It's also, in the context of multimedia extension, it's sometimes also called subword parallel instructions, because the data elements are subwords within a larger normal processor word. They're also called sometimes short vector instructions, because the way they look, their architecture is very similar to vector machines that have been built in the 60s and 70s and that make a re-entrance somewhat now. Why should you know about SIMD instructions? Why does SIMD matter? Why? Because it can provide significant, huge speedups for a whole bunch of application domains. For example, 3D graphics, games, 3D physics, scientific applications, image processing, signal processing, video encoding, video decoding, and so on and so forth. And it does so requiring less power than an ILP, a 100% ILP processor does. This here shows somewhat the evolution of SIMD ISA extensions over the years. Right? Perhaps the oldest one was the PARISC The base ISA was PARIX, and the SIMD extension was called Multimedia Acceleration Extension MAX. It was introduced in '94 as shown in this column, and the number of instructions supported was only 9. This is very small, of course. Sun also followed with their visual instruction set in '95. They already supported 121 instruction. Then Alpha and MIPS joined. And then in '96, Intel also jumped on the road and supported MMX. What is interesting about Intel is that they didn't stop at MMX. They continued. They continued introducing more data types and longer vectors. For example, from '99 to 2007, they introduced several streaming SIMD extensions, SSE, SSE2 up to SSE4, supporting more than 127 different instructions. And very recently in 2011, x86 now also supports advanced vector extension, and in the previous year they also support AVX2. This concludes this lesson. Thanks for watching. In the next lesson I will discuss different aspects of SIMD instruction set extensions, such as the SIMD register file and data types. Stay tuned.